So I wanted to get started. I wanted to introduce Deb Shepard. She's got 14 years experience in the field of sustainability, and she's the owner and chief principal of Riverstone Sustainability. And she's worked with universities like Harvard and MIT, and she's got a bunch of corporate clients, and she also is working with the City of Newburyport on sustainability and energy efficiency and determining what the city's carbon footprint is. And so I'm going to turn the presentation over to her and let her tell you about what she's doing and what you can do.
Thank you. All right, well, once again, I'm glad we're starting on time after the little kerfuffle in the beginning here, but I think we'll have plenty of time to cover our agenda today. So just really quickly, this is what we're going to talk about. So I always like to start with introductions kind of around the room. I see a lot of familiar faces, but also some new faces. So it's helpful for me to kind of get to know you guys, and then I'll tell you a little bit about myself and my business. I'm going to do a very quick climate change in 5 minutes or less, because I have a feeling most of you have already seen sort of the introductory, slides and graphs on climate change, but just to make sure we're all starting from the same place. Then I will define what a carbon footprint is and actually get into the weeds a little bit on how it's calculated. I promise not to kill you with too much chemistry and math, but there's a bit of that in there, so I think it's just helpful for understanding how these footprints come together. Then I'm going to share some of our very, very preliminary findings on the carbon footprint assessment that we're doing for the city. So it's a community scale greenhouse gas inventory. Then I will be giving you a demo of this cool climate calculator. So how do you figure out what your household carbon footprint is? There's a bunch of tools out there, but I'm going to just walk you through this one website. It's free, it's easy to access, and it has options for either kind of a quick and dirty calculation or really detailed analysis, depending on how into data you are. And as you could probably guess, I'm a big data geek, so I like to look at all the detailed versions. But that's something that you guys can take away and do after this lecture if you're curious about your own footprint. And then I'll just give you a couple of quick, top 5, top 10 tips that you can take home for reducing your carbon footprint. I think a lot of those, again, will be familiar territory. But there are a lot of questions that people ask me about all the time, so I tried to hit on some big categories of emissions reductions that you can take on in your own life. And then we'll have lots of time at the end for Q&A. So let's get into it. We have a big group, so I'm not going to necessarily have a roundtable where everybody introduces themselves, but I was curious, how many of you are from Newburyport? Raise hands. Okay, so we have a lot of local folks. Those of you who aren't from Newburyport, where are you from? Anybody want to yell it out?
Salisbury.
Okay, Amesbury, Salisbury, so we've got a lot of regional folks. This is perfect. Anybody want to share what brought them here today?
My mom.
Thank you for your dedication. Anybody else have anything they really want to get out of this that maybe I haven't touched on in the agenda, or something that really excites you about the idea of climate action? No worries if you don't. It's still early in the day. Okay.
How to make adjustments in your life to improve your carbon footprint.
Yep, we will hopefully get that today. But definitely feel free to ask some questions along the way. And I think Linda, where are you? Right back here. So I just wanted to point out Linda Guthrie is, I don't know what your official title is, but
She's just project managing the home energy efficiency initiative for Newburyport.
Yes, so originally we were going to have a little table set up on the side, but we don't have that set up right now. But I definitely encourage you to go meet with Linda if you haven't already introduced yourself to her. Give your contact info to you. Is that how?
It's out there at the table.
Okay. So basically, energy and carbon go hand in hand. You guys may already know that. But that's one of the biggest places where you can reduce your carbon footprint, and there are free home energy assessments that you can have done through the utilities, and Linda can help facilitate that process. So definitely come say hi to her. All right. So a little bit about me. I'm not going to bore you with my whole life story. I've been living here for about 10 years. I have 3 kids, 7, 8, and 11. We love to go to the beach, obviously. That's why we live in Newburyport. My background's in marine biology as an undergrad, and I spent a little bit of time kind of working in a lab, but I didn't want to be stuck in a lab my whole life. I really wanted to be out there kind of, giving compelling reasons to the rest of the world why they should care about the environment and not necessarily just doing research all the time. So that led me to pursue a master's in environmental management. This was at Harvard Extension. So back then they used to only have a certificate program in sustainability, and I was one of their first students that really lobbied hard for them to turn it into a master's program because we knew that there was going to be a need for this and a demand for this. So when I was doing my master's work, I had to do a thesis project, and I was trying to figure out what to work on. So I sat with Leith Sharp, who used to run the Harvard Green Campus Initiative. So way before there was an office for sustainability there was an initiative. And Leith taught this course called, oh gosh, are you okay?
Can you pass that over?
So Leith taught a course about using institutions as agents of change for sustainability. And as soon as I took that first class, I realized this is really what I want to do for a living. I like the idea of focusing at an organizational level, but I was trying to figure out how to turn that into a research project. And so I met with Leith and said, well, carbon neutrality was the big buzzword at that point. It was like the word of the year back in 2006, I believe. So she said, can you make a building on Harvard's campus carbon neutral? And I was like, it's a really interesting question. I don't really know a lot about buildings. I know what greenhouse gas emissions are, but I don't know how to calculate them. And that's what really kind of led me on the career path that I ended up taking. So back then, there were new protocols being released, but nobody really knew how to do it. So I was trying to learn it as I went, and we used a campus building as kind of a pilot case for looking at how to calculate the carbon footprint of a thing, and then look at what are the levers and mitigation potentials that you might have to reduce that carbon footprint. And that's basically what I've been doing ever since. So I ended up getting into the consulting field back, about 10 years ago, or a little bit longer now, to do sustainability for mostly universities, because they were really trying to walk the talk and be leaders in this area. But at that point, most institutions weren't ready to invest in a full-time staff person to do it, so they would hire consultants to kind of come in and get a project started, do some baseline assessments. So I've been doing sustainability consulting for 12, 13 years at this point. I worked at a lot of bigger firms for a long time, but I had a little bit of trouble convincing the powers that be in those bigger environmental firms that there would be a market for sustainability consulting. So eventually, about 5 years ago, decided I was just going to go off on my own, and ever since I've been running my own practice called Riverstone Sustainability. So people ask me this all the time, especially students, what does a sustainability consultant do? So just to try to give you a couple of examples of this, a university, for instance, will want to know how green are we actually, and we'll look at sort of a scorecard of options, a menu of different topics to figure out, well, are you recycling, are you composting, are you, do you have targets for energy efficiency, how are you going to get there? Are you teaching your students about sustainability? How many of those students are graduating having taken a class in sustainability? So we try to find ways to measure sustainability impacts, to manage it, so try to figure out what your priorities are and how you're going to pursue those, and then also to report it out. So this is really important, in the corporate sector especially, to track your sustainability metrics and then be able to share that with different stakeholders. So it may be your customers, it might be your investors, so depending on what sector you're in. There's a really big interest in kind of packaging up that information and sharing it so that everybody else understands how sustainable the organization is. All right, so here's my 5-minute version of Climate Change 101. I actually taught a whole sustainable energy course at Merrimack last year, and we had 3 lectures on this, so I'm going to try to condense this down into 5 minutes for you. But essentially, this picture here is kind of, here's the Earth, and there you can consider a heat-trapping blanket being wrapped around it. So there are these things called greenhouse gases that trap heat and create sort of this blanket around the atmosphere. And what we know is that primarily human activities are causing climate change through the burning of fossil fuels, so oil, natural gas, that sort of thing. When you burn those fuels, you release primarily carbon dioxide up into the atmosphere. That's accumulating in the atmosphere, and it's trapping a lot of this radiation and heating the planet, which causes all sorts of impacts. And I know you guys have had a lot of discussions about climate change impacts regionally, locally. So I'm going to actually back us up a little bit and try to figure out how do we understand what the root cause of that is. So to get into that a little bit more, just again to rehash the basic definitions here, what are greenhouse gases? You'll see GHGs, so you'll hear me use some of these terms interchangeably. If I start speaking in acronyms, please raise your hand and remind me that I need to bring it back down because I'm not sure where everybody's at with a lot of this stuff. So greenhouse gases are the gases that trap heat in the atmosphere. And one thing that's important to note is that they don't all contribute to climate change equally, right? So EPA kind of breaks this down in a very simple way. What you need to think about is how much of those gases are going into the atmosphere. How long do they stay in the atmosphere? So some of them will kind of break down quickly. Some of them stay up there for a very, very long time and wreak havoc over much longer time scales. And then how strongly do they impact the environment? So some of them have a stronger radiative forcing, which means they trap more heat per molecule of that gas. So those are sort of the three factors to keep in mind. This is just a quick pie chart from EPA because people always ask me, how much, what is sort of the breakdown of greenhouse gases going up into the atmosphere? And if you look at it per volume, it's mostly carbon dioxide, so that's why you always hear people talking about CO2, carbon dioxide. But I also wanted to point out that there's other gases there too. So methane is a big one, nitrous oxide, and then what we call fluorinated gases, which is a whole group of other gases. And I will explain, provide some examples of what these are so that you guys can understand that a little bit more. So you may have seen this old management adage, but we always reinforce this when we talk about sustainability and then when we talk about climate action. If you can't measure it, you can't manage it. So we know that there is a problem out there. How have scientists come to that conclusion, and what does it mean, for organizations, for households? How many of you have seen this graphic before? Okay, so some of you haven't done this, but a lot of you have. So this is sort of your classic, the classic example of how they looked at greenhouse gases in the atmosphere over time. I won't go into too much detail here, but scientists have looked at all different types of natural history records to try to reconstruct what are the trends of greenhouse gas emissions over time to show that human activities are actually changing that trend. So this is probably one of the most famous ones where they actually look at air bubbles that are trapped in ice cores. So if they go down to Antarctica and they drill way, way down, they can get these samples of ice that are hundreds of thousands of years old. And then they do some chemical analyses to look at the ratio of carbon dioxide in those trapped air bubbles from long, long ago. And so you see these sort of up and down trends. This is sort of your natural variation here. You have your ice ages, you have your warming periods. So there is always some natural variability in greenhouse gases. But what we started to see around the time of the Industrial Revolution, which I think was probably right around here, is that as humans started to burn more coal, started to extract more oil, natural gas, those sorts of fossil fuels, and burn it more and more to produce power and heat our buildings and all of that stuff. We started to pump more these greenhouse gases up into the atmosphere than had been naturally released over thousands of years of natural records. So what we're seeing now, this was 2007, is a level of about 405 parts per million of CO2 in the atmosphere. And you can actually look up online, I think it's NOAA that gives monthly records of how much CO2 is out there. So when I first got into this, I actually thought it was kind of cool that you could just walk outside your door with an air meter and right away get your CO2 reading. So it's not as abstract as you would think. People that look at indoor air quality look at CO2 levels, so you can take one of these little handheld meters out and go, oh, okay, right now it's 405 parts per million. So the big takeaway here is we're way above these natural anomalies. So what does that mean for us? So Bloomberg has this really cool interactive graphic that I recommend you check out in terms of showing the association between greenhouse gases and the impact on the global atmosphere. Climate deniers will always bring up the fact that there are these natural variations. There's, volcanoes releasing gases, and there are, other natural system effects on a global scale that will cause, ups and downs of greenhouse gases. So what they do on this graphic is they start to talk about, here are all the natural factors, ozone, all these other things that can influence the temperature, global average temperature, and then here are the human-caused greenhouse gas emissions and what the influence of that is. So the big takeaway here is if you track greenhouse gases going up, you see that the average temperature starts to go higher and higher. So you release more greenhouse gases, you're making the planet warmer. That causes all sorts of impacts in terms of weather and, the regimes of animals and plants kind of migrating and disease precedents and all sorts of negative things. This can be a little bit gloom and doom. So the reason I got interested in the topic of doing a carbon footprint and looking at reductions is I was really excited about the idea of shifting that curve and trying to be proactive and trying to avoid some of these catastrophic impacts. Obviously, we know there's a certain amount of greenhouse gases that are going to be percolating up there because of, 200 years of industrial activities. But what can we do now to try to mitigate that now that we are aware of the fact that we are altering a global system that's way beyond individual human action, that we are collectively causing this change that's never been seen in natural history. So this is sort of like our call to action that we need to do something. And I do feel like climate action is one of those ways that you can feel like you can have a positive impact and not be completely frozen with the idea of all the consequences that are coming. All right, so, sorry. So this is just kind of getting back to what the greenhouse gases are, so that you guys are familiar with what the different sources are. So we mentioned carbon dioxide, which is the biggie. So that's really burning your fossil fuels. So you're, around here we're using a lot of natural gas to heat our buildings. Power plants are burning lots of fossil fuels primarily still to produce electricity. So every time you flip that switch somewhere way down the line, there is a power plant that has to burn fuel to produce that power. So methane is another topic that you may have heard a bit about. So as there's more fracking and some of these ways that people are starting to go after natural gas, as it gets harder to find the easier sources, they're digging deeper, and they actually release some of these gases up just by tapping into the earth. You may have heard about the pipeline leaks. Obviously, we've had some really big problems in the Merrimack Valley with pipeline infrastructure being dated and having risks there. But kind of all along the natural gas distribution system, there are these little leaks that are happening, and those are just releasing methane. Natural gas is basically methane, so that's a greenhouse gas that's going up into the atmosphere. Livestock, so you may have heard about the cows. So as they do their digestive process, they're releasing methane up into the atmosphere.
Humans
and then, what? And humans, yeah. I almost put a cartoon up on that. I'm like, gonna try and keep this a little bit like highbrow, but it's come up. And then waste. So if you have a landfill, if there's a lot of organic material, so food waste or yard trimmings, those sorts of things, if they're sitting in a landfill and they're breaking down anaerobically, they're releasing methane up into the atmosphere. Let's see. So nitrous oxide, so that comes from your fertilizers. So you want a really green lawn, and you're putting an N-based fertilizer down. That's actually releasing some greenhouse gases there. And it's also a byproduct of burning fossil fuels, so it comes out of the car tailpipe and out of stack emissions from boilers and things like that. And then this fluorinated gases, this has gotten a little bit more attention recently. So as we start to see the impacts of climate change and a warming climate, we see around here that we have more hot days in the summer, more heat waves. As new buildings are being constructed, they're always putting air conditioning in. People are starting to add more air conditioning to their older buildings just to cope with the more heat that we're experiencing. But what that means is we're using a lot more refrigerants, and these refrigerants are often fluorinated gases. So when you have an air conditioning system, there's actually a little bit of leakage that comes out of those. And we'll talk a little bit more about why that's a big deal, even though it's a small source, shortly. All right, so now, what is a carbon footprint? Very simply, it's another name for what we call a greenhouse gas inventory. So you may hear me say greenhouse gas inventory or carbon footprint. They're totally interchangeable. Basically, what you're doing is you're trying to measure those greenhouse gases that are associated from the activities of whatever entity you're looking at. So an individual, a household, it could be a university, it could be a company, it could be a product. So there's all different, scales that you can apply this methodology to. This is actually an example of a greenhouse gas inventory that I've been tracking for years for one of my university clients. So basically what you see here, and I know this is a little bit jargony, but essentially stationary combustion is burning fuels primarily to heat buildings. So you have like a boiler, it's a stationary unit that's combusting fossil fuels. So that's where that term comes from. This is electricity, so thinking again about those upstream power plants that are burning fuels, you can kind of allocate a portion of those emissions to your usage based off of the kilowatt hours of electricity you're consuming. And then a common thing that a lot of universities look at, even though they don't have a lot of control over it, is commuting. So how many people are driving back and forth to campus and the amount of fuel that's burned just in their day-to-day getting to and from. And then air travel. So there's a lot of study abroad. There's a lot of researchers that travel all over the world. So that's the fuels that are used in those planes is sort of an outlying source. They don't have a ton of control over that, but they do want to account for it in their carbon footprint.
Can I just ask a question?
Yep.
If the university contributes waste to the system, isn't there a cost to that as well?
Yes.
In the carbon footprint, where would that
Yes.
be?
So for this one, that's an interesting point. So there are tools that we use to do the carbon accounting, and there's this one tool that universities typically use, and historically, the way that they accounted for waste emissions, I didn't agree with. So I actually excluded it from the inventory here because I didn't have a lot of confidence in how they were doing it.
Okay.
It gets at, when you do an inventory, and I didn't include a lot of this in here, but you have to look at like a temporal boundary. So we're looking at, our activities for 1 year and the amount of emissions that are coming from that 1 year of activities. A lot of the waste analyses will say, we're sending this waste off, here's 1 year worth of trash, so many tons of trash that goes to a landfill. But then they have the emissions calculations may look at over the lifetime of that material breaking down, you release so much emissions. And it wasn't necessarily allocating it on a per year basis. I know that's really wonky. So we do actually track solid waste generation for this campus, but I didn't include it in this inventory for that reason. Okay, so I mentioned this already, types of inventories, organizations, so companies, institutions, products. This is something we're seeing more and more now. So the bigger companies that produce a lot of the products that people buy are starting to get savvy to the fact that people want to know, what are the environmental impacts of my purchasing decisions, and they prefer to buy something that has a lighter environmental footprint, so they want to know the data behind that. Communities and government, so I will be giving an example of how we're doing this for Newburyport. But cities, states, and countries, they're all looking at their own greenhouse gas inventories. So Massachusetts has some pretty strict targets for reducing emissions, so they actually look at statewide greenhouse gas emissions and report it every year, and they have targets that they're trying to hit for reduction. The countries that are still participating in international negotiations, and I won't get political here, they all submit their greenhouse gas inventories towards the international targets that people are trying to achieve, because really we have to roll this up to that global scale to start to move the needle on global emissions. And then there's projects, which I won't talk too much about, but if there's like a solar project or a landfill methane capture system. So these projects that are done specifically to reduce greenhouse gas emissions, they have a whole separate protocol that they have to do to demonstrate that their emissions reductions, that they're rigorously calculating them essentially. All right, so why do organizations conduct inventories? So I like to bring this up because I think people automatically think, well, yes, we want to measure our footprint so we can reduce our footprint. But there's actually a couple of other drivers out there that are leading organizations to do them. One is risk management. So what are the greenhouse gas risks and opportunities for a business specifically? Are there regulatory drivers? So are there mandatory reporting requirements or reductions that they have to do by law? And then reputational factors, so satisfying your stakeholders. So again, your customers might be asking about this, and this is kind of an example here. So when you're looking at greenhouse gas risks, so view it from the perspective of a corporation, there's been a lot of movement among investors to really push publicly traded companies to disclose what their carbon footprint is, talk about how they're reducing those emissions, but also to talk about what's happening in their supply chain. Is there a risk further up the line that's going to impact the cost of their operations and their profitability because the shareholders have a vested interest in that? And then also, so this example over here is just ExxonMobil having to respond to shareholders really holding their feet to the fire to make sure that they're telling them what risks they have in their portfolio and how they're going to address those. So regulations, you may or may not know here in Massachusetts, there's actually mandatory greenhouse gas emissions reporting for any entity that emits more than 5,000 tons of CO2 per year. So this is typically like hospitals, universities, manufacturers. You can kind of see this is a breakdown of who ends up reporting. A lot of power generation facilities, obviously. So if you're running a power plant, you're burning a lot of fuels, you're producing a lot of emissions. So all this data is up online. It's kind of cool. You can look up specific companies and see if they're reporting. So companies have had to do this for a couple of years now, and cities and states and countries are starting to ask this information because, first of all, they want to know, where's the low-hanging fruit? Who are we going to target for potential regulations to reduce their emissions? So they ask for data for a couple of years, and then you see like the next layer out will be, okay, now we're asking those of you who emit more than 10,000 per year, you have to reduce by 10% in the next 5 years. So the city of Boston actually just did this. They require buildings over a certain size to report their energy data, and they've had to do this for like 5 or 6 years. And just this year, a new mandate went into effect that they have to demonstrate that they're reducing their energy use by a certain percent within 5 years. So this is how the governments are starting to kind of like push the levers on the biggest emitters to reduce. All right, so this is kind of getting back to residential scale, and I was hoping we'd have some of the high school students here today, but I don't know if I don't see any. Yeah.
Sorry, you mentioned Massachusetts is doing this. Are other states doing this too? Are many states doing this?
That's a good question. I would say probably out on the West Coast they're doing more of it, and like the coastal areas tend to be doing a lot of it. I don't do a ton of municipal work outside of what's happening here, so I don't know. But so I like to bring this up just because I do a lot of work with university students, and they already know this, but for those of us who are older, we may not know this. The younger generations are like super tuned in to the idea of climate change. They're learning this in elementary school and high school, so they know this stuff probably better than I do at this point. And what we're finding is that if you survey millennials, they are really concerned that climate change is going to impact their quality of life. They see this as something that they're inheriting and they're going to have to face. But they also say that buying products is really important to their image. So they're the ones that are driving like the Levi's and all these other brands to start to demonstrate what they're doing for disclosing their emissions, and then talking about how they're reducing their emissions and what does it mean when they buy their product. So they're really pushing on these brands to disclose more, but also when they go out into the workforce, they're asking when they're interviewing with these HR folks, what is your company doing for corporate social responsibility? Because they want to work for a socially driven organization. So this is a sea change that we're starting to see as these millennials kind of come out into the workforce and as they get more buying power. So what does that mean for the carbon accounting world? It means that we're starting to see more and more of these product carbon footprints. So I always like to throw my Merrimack students like this one because it was an iPhone. So it's something that they all have. But what is the carbon footprint of an iPhone? When you're looking at a product, you have to take what we call a life cycle assessment of that product. So you're looking at extraction of the minerals and raw materials from the earth, from natural resources, all the way through the manufacturing process and the energy and water and waste and all the stuff that happens in manufacturing, to bringing it to retail, to the use phase, so how much energy is it using when you bring it home, to the end of life. So does it get recycled at the end of life? Does it end up polluting the environment? So what they do is they look at all these different phases of the life cycle and they assign greenhouse gas emissions to it. So for this one, we actually see that the production of the iPhone has a pretty significant carbon impact. And then the end of life recycling. And then the customer use is actually pretty small. So you would kind of think every day you're plugging that phone in and draining electricity, but if you zoom out and look at the life cycle of that product, there's all sorts of upstream emissions that are associated with it, as well as downstream. So it's a little bit of a different version, and I just wanted to show you guys that to get a flavor for it. Yeah?
Can you go back to the slides before, because I was wondering, what country is it that's better than us?
Yeah, right.
France, yeah, I think it's France, and England, and Germany were the ones that are listed there, so, yeah. Oh, was there another question?
Yeah, I wasn't sure. I was reading on the next one. I wasn't getting the colors. It looked a little bit like customer use was a lighter green, and then therefore it was the bigger one, and that recycling was the tiny one further up.
Oh, yes, I'm sorry.
But I
Right.
didn't know.
Recycling is this one. I apologize,
Okay.
I got that flipped. So this is production,
Significantly
this is the
different.
use phase, and that's the recycling.
So we count for a quarter of the use, but
Yeah.
now we leave it on to. That's what we're saying here.
Usually it's on, so if this is life cycle, they must assume a certain use phase. So you have your phone for 3 years or whatever, and over the course of that. So again, the time scales are different when you're doing a product footprint versus an entity organizational footprint. Thank you for that, Cash.
But compared to the orange juice you had picked there,
Yes.
you know, one what is it, a half gallon or something of orange juice?
Yeah.
It's almost 3 times.
Well, so this is grams of CO2, and that's kilograms.
Oh, okay.
Yeah,
Sorry,
so you just
I
have to
didn't
look
see
at your units.
Yeah.
Yep.
That's over the life of the
It's
phone.
steady from.
Sorry.
Okay. No, I'm good.
I have a question here.
Yeah.
How much of individuals' consumption is added to their carbon footprint versus staying with the producer of it? So let's say you look at Apple, but then
Yeah.
you look at an individual who buys a phone.
Yes.
Does that, is it shared or is it?
Yeah, that's like one of the biggest sticking points in doing inventories.
Yeah.
And I actually have a graphic that talks about this a little bit. There is an allocation procedure that we use. So when you're doing a life cycle, like a product footprint, you kind of allocate a certain share of the usage profile to that product's footprint. But if you're doing the corporate footprint, it's handled differently. So you can almost think of it as concentric circles where they call it scopes. It's scope 1, scope 2, and scope 3 when you're doing a corporate footprint. Scope 1 is the stuff that you have the most control over. So you have a boiler on site that's burning natural gas. You have the option to switch that equipment out. Scope 2 is your purchased energy. So you're kind of dependent on the grid, or you have to go to a market-based mechanism to reduce those emissions. And then scope 3 is kind of your catch-all. So there may be some organizations that choose to include a consumer use phase as a scope 3, knowing that someone else might be counting it. So your household might be counting that as well. So there is a bit of overlap that happens there. And everybody just accepts that as long as you're stating clearly what you count in your footprint and what you consider your scopes. So there's just sort of an acceptance that there's a bit of double counting that happens there. Okay, so one of the other drivers, one of the biggest drivers really is greenhouse gas reduction opportunities. So when you do your carbon footprint, it tells you the types of emissions that you have, the relative amounts of those, and where they are within the operations. Is it within your transportation fleet? Is it in your buildings? And that can be used to figure out what your opportunities are to reduce those emissions and to prioritize those efforts. So you're not necessarily chasing down every emission reduction opportunity, but you're going after the ones that have the most impact. And so this again is from one of the university clients. So this is just a single year from that time series I showed you before. But what you'll notice, so this is your stationary combustion, this is your burning of natural gas, this is your refrigerants, your fugitive emissions, and then this is your electricity. Really, if you think about that big picture, this is running their buildings. This is all looking at your buildings. So if you're looking at carbon reduction opportunities on this campus in the middle of the city, it made a lot of sense for them to focus on energy efficiency in their buildings. Obviously, this is going to differ depending on what entity you're looking at, but that was sort of the big takeaway for them, and then it helped them prioritize where they were going to focus their efforts.
Jeff, how does air travel relate to the building?
Air travel's up here.
I know, but what's it?
So it doesn't. So this is 1 year of emissions as a pie chart, right? But if you look at like the proportion of emission sources, the natural gas use was a huge portion, and your electricity was a huge portion, and your refrigerants were a big portion. So that's why those three sources are kind of pointing in at the buildings. Like what's driving that those emissions is operating buildings, heating, cooling, air conditioning, that sort of thing. So the air travel, we don't even have any mitigation measures for air travel for that campus because they didn't, politically they didn't really want to touch it.
So it's the air travel and commute that they didn't touch.
Yeah, it's really, I mean, they have sustainable transportation options there. And what this doesn't show is for that particular campus, it's something like 72% of the students use sustainable modes. So they either live on campus or they walk or they bike. This is the remaining proportion that drives and the faculty and staff that drive. And it's harder to change some of those behaviors. And, if faculty and staff live further away from campus, you can't get them to move closer. You can't get them to move closer to a commuter rail. So those behavior changes tend to be really tough to go after. All right, so again, kind of zooming out, carbon and energy reductions equal cost savings. So when people talk about sustainability, I do a lot of green building projects. People think green building projects cost more. Sometimes it's an uphill battle promoting sustainability initiatives. What I love about carbon and energy projects is that there's a built-in payback to every one of these projects. So as soon as you go to switch from a CFL to an LED light bulb, you are right away going to start to see savings on your monthly utility bill. So you may have to spend a little bit of money up front, but over the long term, you're saving money. So the other thing to keep in mind is that there are a lot of utility rebates, especially here in Massachusetts. So definitely recommend always looking for those rebates when you're buying something up front. The rebates are actually designed to offset any incremental cost that a green measure has over a standard measure. So you're putting in a boiler system, and the high efficiency boiler costs 10% more. Typically, you'll see a rebate that accounts for that 10% and pays for it up front. So that's how they try to get you to go after the higher efficiency technologies. So one of the big things that I always tell my university clients is capture those savings. So don't just install the light bulbs and forget about it. Calculate, okay, I'm swapping out so many light bulbs. They run for 3 hours a day. It's going to save us so many kilowatt hours on our monthly bill. Set up a savings account and switch that money, transfer that money periodically over into a savings account. And then you'll find a year later, you have those savings set aside. And then you can go after something that's a bigger project that you wouldn't necessarily have the budget for. So it's the idea of kind of reinvesting those savings into efficiency over time.
Do you know what the life cycle cost of the LEDs? Yeah, but I mean, like you give the iPhone.
I don't know off the top of my
My
head.
experience with them is they fail sometimes.
Yeah.
And they,
It's a good point. So, and I actually heard this a lot from my university clients when they were starting to switch over, that all these vendors were saying, oh, we'll swap out your light bulbs, we'll swap out your ballasts, all this stuff. What ended up happening is the utilities heard a lot of this feedback, and they got about which types of bulbs and which types of ballasts they will provide incentives for. So what I always do is refer back to whatever National Grid or Eversource is giving you a rebate on, because they have certain standards that they expect the manufacturers to meet. And those standards require, fail testing and all that sort of stuff to make sure that you're buying a product that is going to last as long as it says it is. Doesn't guarantee it, But it's a better bet than just buying like the cheapest LED bulbs that you might see at a discount store.
Yeah, well, I buy them at Home Depot.
Yeah.
They fail. They don't just not work. They
Yeah.
start flickering.
They flicker.
Yeah.
Yeah.
And
Yeah.
so I ship it back to the company. They send you another one. but,
Yeah.
And then flickers.
Well, after a while, they start flickering again.
Yeah, well, I know like some of the first generation LEDs did flicker because they weren't, the dimmable switches they weren't that compatible with them. I think some of the newer ones are better about it.
They're supposed to be.
Yeah. 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 So there are always some growing pains with some of these technologies, and it's the early adopters that, try to do the right thing, and then we realize that it takes a little bit more to get things
The other
working
thing
right.
is that with the LEDs, in this climate here,
Yeah.
you really need to heat your house 6-7 months of the year.
Yes.
So the incandescents, you're really not wasting. You're helping to heat the house up.
Yes, you do.
It's not the most efficient. It's not
It's
as
true.
efficient as a heat pump.
Yeah, they do actually release heat.
They release
They do.
heat.
So the thing to keep in mind though is, so electric, not that you're saying electric heat, but if you look at electric heat versus other heating systems, electric heat is the least efficient, and there's a lot of embedded carbon
Right.
being wasted, you know what I mean? So you're better
I'm
off
just
having
saying,
a
you
high
get a little
efficiency
bit
heating
back.
system and then LED lights to go with it, but I hear what you're saying. All right, so how do you measure carbon footprint? So you have to identify your boundaries, what's in, what's out, what time period are you looking at, what assets are you accounting for. You have to collect data, so we call this activity data, so that might be your utility bills. For a city, it might be a transportation study. And then you have to calculate your emissions, so we use software to do this. You can do it in Excel, it's a little onerous. And there are industry standards depending on what you're trying to calculate. And then you report that information out to your stakeholders. So this is what I was referring to earlier with the scopes. This is an extremely busy graphic, but if you're doing a corporate footprint, again, they're kind of looking at your upstream, what's happening on site, and then downstream. So this is sort of your life cycle perspective again. These are like greenhouse gases up here, and this is how they're accounting for it. So the scope 1 is the stuff that they have direct control over. Scope 2 is your indirect purchased energy, so that's your primarily purchased electricity. And then you have these upstream things that you can choose to measure, or these downstream things that you can choose to measure, knowing that you don't have as much control over those. So this is just kind of giving you a framework for how we categorize them. What does this mean in a household? Typically what we see in a household footprint is people look at their home energy use, their transportation, and their waste. You can look at purchasing practices as well. And I'll give you an example of that shortly. I'm gonna try to go through this relatively quickly. Chemistry was not my favorite subject as an undergrad, but I can't escape it when you do carbon accounting because it really comes down to chemistry and basic math. So what you're doing is you're taking your activity data, you're multiplying that by some sort of emission factor, and then you multiply it by what we call global warming potential, and the result that you get is converted to units of metric tons of CO2 equivalent. So you might hear that, metric tons of CO2 equivalent, that's what that means. So that's a way for accounting for not just CO2, but your methane and your N2O and the other emissions, so that you have kind of a common unit that you can roll all of that up into. All right. So we talked a little bit about the fact that some of the greenhouse gases have a stronger radiative forcing, so they're more, intensive in terms of what they do in the atmosphere, and some of them last much longer in the atmosphere. So scientists came up with this thing called a global warming potential to try to account for that, and basically everything is compared to carbon dioxide. So you see carbon dioxide has a global warming potential of 1 over 100 years, but what's really interesting to note here is the lifetime in the atmosphere. So every molecule of CO2 that goes up lasts for at least 1,000 years in the atmosphere. So if we all went carbon neutral tomorrow, we are stuck with a certain amount of greenhouse gas emissions that are going to be up there for a very, very, very long time. So we are messing with a system that's much bigger than us on timescales that we can't even wrap our heads around. The other thing that's interesting to note, and you may have heard this, is so methane, for instance, has a shorter lifespan, but it's 28 times as potent as CO2. So even though we're not releasing as much methane as we are CO2, it has a really big impact proportional to the amount that's going up into the atmosphere. And then this is actually one of the refrigerants that a lot of air conditioning units use. So it's the 134A, and the global warming potential of 1,300 times CO2. So if you remember that EPA pie chart that showed that the fluorinated gases were a tiny fraction of the amount of gases that are being emitted, it doesn't seem like a big problem until you take into account the global warming potential. So even though this tiny leak of refrigerant has a much bigger proportional impact.
Is there anything that measures the impact?
Yeah, so that's what the global warming potential does. So I'm going to show you a calculation. Don't kill me here. And I wanted to show electricity because that's like one of the bigger sources that we see. So power plants burn fossil fuels. When you burn fossil fuels, you release carbon dioxide, methane, and nitrous oxide. When you're looking at electricity emissions, you have to look at the whole grid that's supplying your electricity. So here in New England, we're in this little green grid up here. And what EPA does is they look at all the power plants that supply that grid and look at how much fuel they're burning and how much emissions they're releasing, and then they allocate all of that per kilowatt hour that's going into the grid. So every time you look at your electricity bill and you say you're using 50 kilowatt hours, you multiply those kilowatt hours times that emissions intensity. Here's all the calculations.
Could we go back to that last slide and you tell us what those colors mean?
Thank you.
Yeah, okay, so, and this is kind of a complicated thing a little bit, but, so electricity isn't, so it doesn't go power plant straight to someone's town or someone's home, right? There's a whole system of power plants that all feed into a grid. Those grids are somewhat regional. There's a little bit of overlap between them. So what EPA has done is they've kind of carved out these regions, like these little regional subgrids, and that's what they'll say, in New England, your greenhouse gas emissions intensity is X, based off of the power plants that are supplying you. So depending on where you are in the country, you have different carbon intensities to your electricity. So in the Midwest, they burn a lot of coal, so they have a more carbon intensive electricity grid. We have a very clean grid here in New England.
What do we have in New England?
We have a pretty clean electricity grid, meaning the amount of emissions per kilowatt hour is lower.
So the color in the spectrum would be red is really bad?
No,
green is really good? Or
No, this is just like for illustrative purposes. There's no intensity associated with the color scheme here. Yeah, it was just
Color is for the region.
Yes, the color just shows you the different regions.
Are
There's
there
no
numbers
intensity.
in there?
What'd you say?
Are there numbers that I can't read from back here?
No, these are just the acronyms for the grids. So there's an Excel file that EPA publishes, so you would look up New England and it would be the NEWE grid, the NEWE grid, and then it gives you factors.
So it's color regional grids.
It's just, this is just kind of to illustrate the fact that depending on where you are and what sub-region you're in, there's different emissions factors. So.
Do they look at it on a per person basis within the region?
No. So
No.
what EPA is publishing, because the power plants have to submit a lot of data to EPA, so they look at what the power plants are doing, and like in New England, we have a regional grid operator that works with all the power plants. So they're called ISO New England, so all the power plants report to ISO, and then ISO reports up to EPA. So EPA is rolling all of this up kind of on a grid basis, and so you can look at, for the grid, how much electricity was produced, how many total emissions were released, how many annual emissions per kilowatt hour supplied. And so they kind of look at it more just on the power profile, but not necessarily on the population served. But you can use that data to calculate your carbon footprint when you have your electricity use. I'm not going to kill you with all this, but basically, take your emission factors for each of the gases, your CO2, your methane, your N2O. You multiply your annual electricity use by that factor, convert it to metric tons. So you'll see for CO2, it's just metric tons of CO2. And then for these other gases, so for methane, here's your usage times your kilograms of methane released times the conversion factor, and then here's your global warming potential. So you may only be, releasing so many kilograms of methane. But then you multiply that by 25 to account for the fact that it has that additional kind of atmospheric forcing, so the additional heat that it's releasing up into the atmosphere. So that's where you get that kind of the extra punch of those gases that have a bigger effect.
So is this a shortcut way to determine what the output is if you just take the ratio of the top number and the bottom number and apply it to your home use? Okay, wait a minute.
The top number in
The 100,000 kilowatt hours
Yeah,
to 30, so that's
you could do it that way.
Take a ratio and off you go.
Yeah.
Okay.
So what I'm going to show you is there are some really nice, easy online software tools where you don't have to do these calculations. I made my undergrads do this and they hated me for it. But I wanted them to understand the steps that are involved in the chemistry that's involved. You won't have to do this to do your own household footprint. This is just sort of an illustrative example. So I'm going to show you really quickly what we're doing with the City of Newburyport, and then we'll get into that demo of how you guys can calculate your own household footprint. You may already be familiar with what Newburyport's doing, but I wanted to kind of give you the big picture. So Newburyport's been a green community since 2010, so they're definitely a leader in this area. They've been tracking municipal energy use, and they had a target to reduce municipal energy use by 20%. So we already had kind of a good handle on municipal energy and carbon emissions. Within the master plan, there were a series of sustainability goals that were included in that. One of those is net zero energy community by 2050. Do you guys all know what net zero energy means? Most of you do. For those of you who don't, basically it means you use a certain amount of energy per year, and to get that back up to zero, you either have to produce enough renewable energy to supply that, or you purchase renewable energy credits or find some other way to kind of equalize that so that you're not just taking energy out, but you're also supplying it to get to this net zero value. Newburyport's also an MVP community, so what that means is there's been a lot of work done, as Mike knows, on vulnerability preparedness. So when we talk about climate change impacts and being prepared for extreme weather and all these other changes that we're going to start to see because of what's happening with climate change, the city's trying to be really proactive in planning for those and pursuing action grants to actually implement those projects to make the city more resilient.
Do you know what the current municipal energy use is in the city, kilowatt hours?
I don't have it off the top of my head, but Molly does. Yeah, they do have those numbers, I just don't know it off the top of my head. So one thing that I was helping Molly with a little bit this summer was this C40 Cities commitment. I don't know how many of you guys heard about this. So some of you have, but most of you haven't. So C40 Cities is like the biggest cities in the world that are trying to be leaders in sustainability. So we're talking about Paris, New York, San Francisco, like heavy hitters, really big municipalities, but also cities that are at the forefront of a lot of this energy and carbon planning. So C40 Cities put out this net zero carbon buildings declaration that any city could sign up for. And essentially what it means is you have to set goals for new construction, for municipal buildings, and for all buildings to eventually reach net zero energy. So it's a very aggressive target. It's really hard to get to net zero, especially with existing buildings. But cities are recognizing the fact that we aren't acting fast enough to curb our emissions, and we need to start to make some drastic actions to really get us there. So Newburyport signed on to the C40 Net Zero Carbon Buildings Declaration. It was one of only 19 cities across the globe to do it, so I think it's a huge bragging right, but it's also driving a lot of our efforts for carbon mitigation in the city.
So when you say all buildings,
Yeah.
are you talking all municipal buildings?
Nope, all buildings,
All
whole
residences?
communities, everything.
So,
How are we going to do that?
So it is residential homes.
It is, yeah, so all new buildings, basically what this means is looking at new construction and when projects are getting permitted, how are those projects going to be net zero? Those are the first ones. So when you're starting from scratch, it's easier to do net zero because you can do integrative design to get a greener building. So they're going to start to push that agenda. Municipal assets net zero, so looking at all of the municipal facilities, the schools, wastewater treatment, which is a huge energy hog. So looking at all the municipal operations and figuring out how to get those to net zero. And then lastly, what do we do with all the existing buildings within the community? So that would be residential, commercial, industrial buildings. That's a huge lift. These are very aspirational targets.
You could do it by creating enough wind turbines without changing anything, just build.
Yes. Yeah, and that's what we see a lot of sort of, off-site renewable energy agreements that are starting to happen to help the buildings get to net zero or to switch to electrifying rather than using fossil fuels, things like that. Was there another question? Yes.
I can't read the years on the slide. Would you mind?
Yep. These ones? Yep, okay, so the goals that are in the declaration are all new buildings net zero by 2030. And then all municipal assets net zero by 2030. And then lastly, all buildings, which is like any building in the city, net zero by 2050.
Thank you.
We realize these are extremely aggressive targets. We have only started to talk, just begin talking about what policies need to happen to get us there. But we're setting the bar high to get started.
Deb, who's the driver of all this, given what's going on? I mean, if we set the goal,
Yeah.
where's the plan to
So
make it
the
happen?
mayor signed off on the goal, and there was a draft action plan that had to be submitted to C40. So if you actually look up on C40, you can see all of the initiatives that Newburyport's already written. These are the things we're already doing to get us in that direction, and these are the areas we're going to start to prioritize. So there is sort of a framework for how the city's going to get there, and Molly
This is
and
what the
EAC
Energy Advisory
yes,
Committee is working on.
Exactly.
And the Towards Zero Waste.
Yeah, so there's a lot of different stakeholder groups that are moving towards these targets. Okay, any other questions on that? We're good. Okay. So where are we with the community scale greenhouse gas inventory? I promised Art I would bring this up. So maybe a year and a half ago, we had a storm surge meeting where we were doing some just planning. What does the group want to work on? What do we think is a priority for the region? And one of the topics that bubbled up was doing a carbon footprint for the city. So we sat down and met with Molly at the city, and I basically offered to pull together a community scale inventory. For me, it was it's a learning curve because I do a lot of corporate work, and I was just curious how it works for a community scale inventory. So we've been learning as we go and kind of developing methods, trying to figure out what kind of data we have on the city, not just municipal, but what's happening within the whole community. So we're trying to develop a baseline for understanding the emissions impacts of what's happening here, and hopefully use it to inform some of those policies and plans and targets that I just talked about. And this is the first of many, engagement processes that we're hoping to, bring this information to the schools, to have more events like this, just to share with people who are curious and hopefully drive some of that behavior change that we all need to pitch in to reduce emissions. So that's sort of the backdrop here, and we're coming in on the home stretch. I'm hoping to have everything finalized by the Green Expo, so that's my final target here. But I just want to put a little disclaimer out that this is very preliminary draft data, so we are still kind of working out the kinks in this, so don't hold us to these numbers because there's still some sources that we're filling in the gaps on. But this is where we're at right now for the city. We're looking at just under 200,000 metric tons of CO2 equivalent per year from community activities. And so what we're finding is primarily natural gas, but some fuel oil, so burning fuels for stationary combustion, so for heating, essentially, is almost a third. The fugitive emissions, this is what's happening in the gas pipelines, kind of all the way back to where it's being supplied. On-road transportation is the biggest one, and within that, residential transportation is the biggest single source that we've seen so far. So people commuting back and forth. We have data on vehicles that are registered in Massachusetts, and we have data on the amount of miles per registered vehicle. So we have an average vehicle miles traveled for a resident of Newburyport and the total number of vehicles in Newburyport, and we came up with this number and realized it was really, really big. So it's going to be a tough one to push on, but it just shows that transportation is going to be something that we really need to focus our efforts on.
Deb, how
Yep.
was that data collected?
So, yeah, it wasn't me. So the state has all the data on inspection records for every vehicle. So they know, and they didn't give me the micro data, but it's, you know.
Does include mileage.
Yes, so when you go to get your car inspected, it looks at the mileage, it knows the make and model and the year of your vehicle. Like, there's a lot of detail in there. So there's this thing called the Massachusetts Vehicle Census that a regional planning authority closer to Boston had requested the data, and they distilled it down so that you can look up, you know, for Newburyport, total number of residential registrations, total number of commercial, vehicle miles traveled, and from there you can extrapolate out the emissions. So, yeah, it's pretty amazing. It's kind of cool.
This is really theoretically now.
This is 2016 data was what we had worked with, but we are tracking the energy data for future years. So.
Wow.
Yeah, so bus travel is built into this onward transportation, but it was a tiny, tiny fraction. We looked at the route miles within Newburyport for MVRTA, and we also looked at school buses. But what I found is, and this is very typical when you do a carbon footprint, it's hard to track down the data on those sources, and we do an estimation, and we find that that source ends up being a tiny fraction of the overall footprint, but we at least have some numbers around that now.
How did you deal with the electric cars in that total number?
Yeah, so we asked National Grid for total electricity use for the city and total natural gas use for the city. So they gave us the totals for those, only broken down to the level of residential accounts and commercial accounts. We know the electricity use associated with those vehicles is in there somewhere, but I can't tease it out because I don't have more granular data.
An electric car isn't appearing in both colors, the yellow and the green, because it's a car, but it's also going to have electrical use.
Yeah, so the electricity use is captured in the electricity. In theory, however many number of electric cars that are in that vehicle registration data, there is a bit of double counting where they would be, because we're averaging it. We have, you know, so many cars times so many vehicle miles traveled, assuming a certain percent is gas versus diesel, and the vehicle type is a lot that goes underneath that. So right now it is being double counted a little bit because that state data set on the vehicles, it didn't give us enough information on how many EVs or hybrids. It didn't give us any resolution on that. So I had to use kind of like, you know, national statistics to figure out what the spread of vehicle types is. But yes, that's a good point. Yep. In the back, sorry.
I'm curious if food consumption is accounted for.
Not in here. There are ways to get at it. It's in the household one I will show you. And there are consumption-based sources that you can calculate for a community scale. We had our hands full getting to this, so I wasn't quite ready to take that on. But there are some communities that are starting to do that because realizing that bigger, you know, life cycle impacts are definitely going to be a big contributor. Yep.
I find it hard to believe that commuter rail is zero.
Yeah.
It's not zero. It's less than a certain percent there.
It's very small compared to the rest.
But let me put a little disclaimer on that one as well. So I was scraping by with the data that I could get, and there's different ways you can do it. So I can get the total energy use of the commuter rail system and figure out per mile how many emissions per mile, right? Mm-hmm. So what I did, and this is, again, very rough, was just looking at the miles of track that are within Newburyport, because the way we handle some of the transportation is just within boundary transit, recognizing that there's more beyond.
Sure.
If we had a more detailed transportation study that said so many people ride the commuter rail and this many of them go to Boston versus other destinations, we could start to add to that. I couldn't find it readily available. It may be out there, but again, it was a bit of a learning process for me because I don't usually do the regional type of studies. Yeah. Yep.
Kind of hate to bring it up, but the grid electricity, 28%.
Yeah.
We have all these new marijuana plants going into cultivators, going into the industrial parks, kilowatt hour
per
day.
Yeah.
More than that.
Yes,
So
so
has anybody,
it's not factored in, this isn't modeling, this is purely what we know is happening. I can tell you within the electricity, if you split out commercial versus residential, in the commercial sector, electricity is the dominating emission source. In the residential sector, it's natural gas and heating. So we do know in the commercial sector, which is very typical, electricity tends to be a bigger emission source because they have a lot more electricity demand for their equipment and HVAC.
so this doesn't include the industrial?
It does include whatever was in existence as of 2016 and pulling from the grid. We have that data, but I can't break it down to subsectors. We're starting to model it a little bit, so we're working with the assessor to look at the types of buildings in the city and what industries are here to try to tease it apart. But at the scale of doing the community inventory, we're just looking at aggregate numbers. So we're just starting to tiptoe into what sectors are here and which ones are more energy intensive. But it is on our radar, for sure. Yes.
I just wanted to know what electricity T&D losses.
Yes. So that is similar to the fugitive emissions for natural gas. There are transmission and distribution losses from the grid. So from the power plant all the way till it gets to your house, there are some line losses that happen just in the, converting the power over and going through the transformers and stuff like that. Wow, this graph has generated so many questions. Yeah.
There's a gentleman over there that's been raising.
Okay, I'm sorry.
And then I.
Go ahead, Lon, is it you?
Oh, sure.
Yeah.
Okay. I'll tell you one thing the city could do over the next 10 years, and probably over 5. I drive my electric car into town almost every day.
Yes.
I can either park at the Autobahn and plug it in,
Yep.
or I can park at the library and plug it in.
Yes.
That's it.
Yes.
And we're going to add 5 whole places, I understand, to the parking garage.
Yeah, okay, so
And in
what...
10 years, there's going to be a lot more electric cars than there are now.
I absolutely hear you. So I want to back up and just say I'm not speaking on behalf of the city, so I don't want to misconstrue what I'm interpreting with my data with what the final policies are.
Yeah. This is easy fruit to pick.
Yeah, so we have started talking about that. I can tell you with my other clients in the state, it's a little bit easier down in the city because they use Eversource, and Eversource has a ton of grant money out for this right now. The utilities want to get into the EV charging station game because they realize that's going to be a new market for them. So they want meters. They don't want those charging stations to be run through a building account. They want it to be on the street. Here's the meter. You pay Eversource, and they have different demand rates that they're going to charge because it's a totally different electricity use profile than like building electricity use. So down in the city, what they're doing is Eversource will pay for everything from here's where you tap into the power line, here's all the engineering and the cabling and the trenches that need to happen to get it to the final pad where that parking, where the charging station will be. They'll cover all of those costs. So there is some grant money coming out from the state to promote that, recognizing that electrification is coming and people are moving in that direction. So yes, it is percolating.
It'll impact your biggest wedge up there.
Yeah, and it's tricky because we're adding to the electricity load, but we're reducing the fuel. So there's, there's a little bit of...
if you buy green energy to run them.
Yes, exactly. Yep, and that's what a lot of people do when they move towards net zero.
That's what I do.
I don't want to be a broken record, but getting back to the commuter rail, zero, I would think that if you look at Newburyport residents who have monthly commuter rail passes, they tend to be commuters who use it 5 days a week.
Yes.
You could get that very easily from the MBTA, and that would give you a good start at how many residents in Newburyport are using commuter rail 5 days a week.
Yes, and like what type of pass they have.
Right.
Yeah, so that's I've done that for some of my university clients using their university data, but I've never gone to the MBTA to ask them. So this again was sort of like, here's our rough draft first pass, recognizing that every one of these sources could be like a mini study for an intern or a grad student to like really dig through. But we just wanted to have, order of magnitude, recognizing that there are some big buffers on the data that we're displaying. So, yes.
What is the big blue?
This one here?
Yeah.
So this is, again, kind of a wonky term, stationary combustion. It basically means burning fuels for heating. So it's primarily natural gas, a little bit of fuel oil, and a little bit of propane. And again, like we have great natural gas data from National Grid. the fuel oil and the propane, we had to estimate so many, buildings of a certain type uses so much propane per year and extrapolate up. So there's a little bit of estimation in there. Yep.
What are your chances, not in that graph, but if you have such a low point there where they're not using commuter rail and we're not doing those things, what is being done to get that up on a bigger level in the state? You have the commuter rails here in New England. They don't have them in the rest of the country. You could use them. And the City of London, for instance, charges you to drive into London.
Yeah, I mean, that's what we're starting to see.
Those sort of things are coming, aren't they?
These are sort of, it's that bigger discussion, so beyond just the scale of Newburyport, like how would residents in a suburb advocate for a better regional system?
The big savings in that thing right there is commuter rail. I mean,
it is, and if you think about it, because I've tried this, it's that behavior change piece too, getting people comfortable with the idea of I'm going to let go of my car, I have to go all the way to Boston. And so as a working mom, I did it for a while. If my kid is sick up in Newburyport and I'm commuting from Boston, it gets tricky. So what we see in the city is bigger companies have support programs for their employees. So they try to encourage commuting by commuter rail and public transit, and they'll have emergency ride homes. They'll give you an Uber certificate or something, so that if you have to dash home and you're not dependent on that commuter rail schedule, it gives you that willingness to try something different. So it is a bit of behavior change and culture shift. Those are really hard, but it is going to have to be things like that that get our transportation over to more sustainable modes.
What about the bus? That's included in the orange? The bus
is included in on-road transportation. And again, it was just looking at the miles traveled within Newburyport based on a schedule. So it's a rough number. I don't have ridership data and that sort of thing to figure out where there might be more potential. But those are all kind of next steps.
What's the green pie? The green slice?
This one here?
Yeah.
This is electricity.
Oh, okay.
Yep. Can I move on? Is that okay? All right. I don't want to rush you guys. I'm excited that you're so excited about this because we've been working on this for a while.
In 2050, would this be all green, and then the grid would be all sustainable? Is that pretty much?
Yeah, I mean, in theory, if we're going for net zero, right, you're reducing your emissions to nothing. There may be some emissions that still happen, but you offset it. So you may be purchasing green power from, solar at a big solar farm or a wind farm. So those types of market mechanisms are being explored to really get to those zero targets. There's also things called carbon offsets. So for like your fuel combustion, if you're kind of stuck with a natural gas system, you can buy carbon offsets. So sequestering carbon in so many trees or landfill gas capture, and you buy the environmental attribute of that project and attribute it back to your footprint. So there are ways you can kind of buy it down, but what we always try to promote is the efficiency and the actual reductions first, and then the market mechanisms later.
Can I do one more question? Sorry. How do you incorporate like the use of a fireplace, or people have fire pits, and some people have wood-burning stoves for a source of heat? Is that in there?
So
particularly when you're doing your own personal.
For the sources that we couldn't get from big utilities, right? So we have the natural gas and we have the electricity, but we didn't have fuel oil, we didn't have propane, we didn't have wood-burning stoves. There is a national survey, it's the American Community Survey that the federal government does every couple of years. And you can look up the responses from Newburyport residents and then kind of get a demographic view of what does it look like in Newburyport, what type of homes do people have, how are they heating them. And wood stoves, it was listed in there, but it was a tiny fraction, and it was so small that we didn't really estimate it. The other thing about wood that's tricky is it's technically a biomass. So it doesn't go into the carbon footprint the same way. There's actually a whole separate accounting of biomass because of the fact that it's short-term cycling of carbon. It's not the same thing as liberating fossil fuels that have been buried and go up into the atmosphere. It's something that if you're regrowing the trees, it's in theory going back into that biomass and it cycles more quickly. If that makes sense.
Makes me feel good.
Yeah, so that's why people are looking at biofuels and things like that, because it is a separate category that's lesser impact. But there's still a lot of debate in the science on how to account for those emissions, and that's why most inventories you just treat it as kind of a separate subcategory.
How about smoking too? Does that go into your personal?
I don't think so. No, I've never seen one for that, but that's a good point. Yeah, I've never seen that. All right, so I don't know which time. We've got some time. You guys want to look at the personal carbon footprint calculator? I think I'm losing my voice. I didn't realize I was going to be gabbing this much. All right, so there are lots of personal carbon footprint calculators out there. EPA has a good one. I really like this UC Berkeley one for the reasons I mentioned at the very beginning. I'm a data geek. I like to get into the details. But it gives you kind of a simplified version and it gives you a detailed version. So there's different ways you can do this, but it should at least give you a sense of what your carbon footprint is. So I don't know if we have to go through all of this, but you plug in your zip code, how many people live in your house, what's your household income. So this is sort of your demographics. Click next. So your vehicles, right? So you can add if you have multiple vehicles. You can switch if you have electric or if you have diesel. If you know your mileage, you can put your actual mileage in here. If you don't, it gives you kind of a default. What's your miles per gallon? And maybe it's down here. And you see that it kind of shifts your numbers as you go. So that's... Yeah, so there's like, here's your simple versus advanced. If you take public transit, how many miles a year do you take it? So maybe you never go on a bus, so you put 0 there. Or if you're taking a transit rail or commute rail, you can put your specifics in. So this is like as much time as you want to spend on this, or you can just use some rough numbers.
It has air travel.
It has air travel in here. So say you're doing, like one big trip a year, and then you go to next. So this is your energy use in your home. So there's a default of, you can either do how much you spend per year or how many kilowatt hours per year you have. Are you buying green power? So some people buy green power through the utility. If you do, is it 20%? Is it 10%? And that, again, will kind of shift what's happening. So in real time, it's adjusting your footprint based off of your inputs. If you use natural gas or heating oil, again, you just kind of plug the stuff in. So what I recommend people do if you really want to get a detailed view of your footprint is pull up each of your utility bills. For your, I didn't have time to do it for today, but on your electric bill or your natural gas bill, if you look at it really closely, usually in the lower left corner or somewhere in the documentation that they send you each month, they give you a trend. So, this month you used this much, last month you used, so many kilowatt hours the month before. So it gives you kind of like a 12-month total. So you can actually get your annual usage pretty quickly by looking at your bill. So you can plug that in here, and then it'll tell you what your emissions are, what size home you have, and then water use. Are you more efficient with your water? This is sort of a guess, right? Whether or not you take you have teenagers that take long showers, or if you're just, taking
and if your water heater is wrapped.
So that wouldn't be in the water usage, but I guess, no, I guess if you're running it, if you're running it.
It would be in your electric.
Yes, yeah. So that'll show up in your electricity. So you just kind of step your way through this, right? And people have mentioned this a couple times, like the consumption-based factors. So if you're looking at your diet, this is actually a big topic. A lot of people are trying to eat a lower carbon diet, if that makes sense. And so you can adjust these levers, right? So do you eat kind of the average amount of servings of meat and fish and eggs? Are you vegan and you put it down to 0? Are you eating a lot of grains and baked goods? So there are all these sort of built-in factors underneath that, and those are those life cycle factors of how much carbon intensity goes into raising the beef, growing the grain to feed the beef, raising the beef, turning it into your steak, and then it goes on your plate. So there's like more carbon intensity to a meat-based diet versus a plant-based diet.
And is the methane measured somehow?
Yeah, that's all built into this. Yep. So you just kind of put some of these factors in here. You can tweak all these little, characteristics. Whoops. Okay. So they also have kind of your purchasing power built in. So the categories here are a little bit strange to me, like the goods versus services, but you can really go into detail. How much are you spending per month on appliances, clothing, paper? So there's factors for all of these things that are kind of built into this. Your services, your healthcare, medical. So these are, again, like if you think about that scope 1, scope 2, scope 3 for your household, these are all your scope 3. So you're buying stuff and somewhere upstream or downstream there are emissions associated with that. And they put some assumptions in here to get at those.
What do you think it takes for a person to do this? 20 minutes, half an hour, an hour, 5 hours?
To gather your information.
With
Yeah,
information gathered.
like if you go through like the detailed one, maybe 2 hours, you know? If you do the quick one like this, I mean, this could be as quick as like 15 minutes, just to get kind of a quick and dirty number, right?
The big question is how much carbon does it take?
Yeah, right? I know. As I 20 minutes all my burn all this electricity to share this information, trust me. All right, so let me see if I can get to the end of this here. So at the very end, there's this thing called take action.
We don't want you to go.
And so what we're seeing here, and I know I didn't really make too many changes, but here's your annual carbon usage. Here's some of your upstream car manufacturing, natural gas, electricity, your upstream impacts of getting water to your house. It takes a lot of energy to get that water to your house. The embodied energy of constructing your home, and then what you're eating. And then this is sort of your purchasing. I guess I didn't have anything with the services. So this is your, in theory, your footprint. So 42 tons of carbon dioxide equivalent per year. I wouldn't put too much credence in the average because I don't think there's a big data set for Newburyport in here. So don't necessarily look at the relative comparison, but it's good to know. I'm like using this like as a touch screen, sorry. I'm so used to that on my laptop. I'm like, so this is a way for you to at least have order estimates, right? And then what I really like about this tool as well, and again, these numbers are a little bit rough, but if you wanted to make some changes, so what are my climate actions that I'm going to do to reduce my footprint? You have to tweak some of these numbers a bit because they're a little bit outdated, but you can pledge to make a change. I'm going to telecommute to work, right? Let's see if I can get this to work. So as you make these pledges, you'll see these little reductions. So it starts to push. So you can see if I make a change, it's pushing my emissions down. Yes. Yeah. So again, it's an approximation, but at least you're like, oh, this is going to make a big impact. This isn't going to make a big impact. That's kind of the scale that we're looking at here. And then within each of the options, you can, again, kind of tweak it. I'll ride my bike 20 miles a week instead of driving this car that I put in earlier. So you can really customize this and have kind of your own household climate action plan built for you. So that's basically it. So I highly suggest you check out this calculator, and you can get a sense of what's happening in your own house. And you can just start to play around with what those different actions are. One thing here. So UC also did this study. So they looked at that American Community Survey data, and they tried to estimate what the average household footprint is by city. So you can actually zoom out on their map and look at the whole country, and it's really interesting for looking at social equity issues, and some parts of the country are very carbon intensive and others are not. It has to do with rural versus suburban versus urban, how much you're driving, and so there's a lot of interesting stuff there to kind of read through. But I just sort of zoomed in on Massachusetts, and one of their big takeaways was If you live in a city or if you live along a corridor that has a good commuter rail system, you tend to find lower carbon footprints. So there's economies of scale to living in a smaller home or apartment in the city where you're using only public transit versus living somewhere out in suburbia where you have to drive 70 miles every day to get back and forth to work. So you do tend to see like higher intensity. So there is a rating associated with these colors. So green is lower carbon footprint, red is higher carbon footprint per household. And then for Newburyport, the average is 48 metric tons for whatever that's worth. And you see transportation is the highest here, so that kind of correlates with what we're seeing in our data as well. So there's lots of fun stuff to look through here. Yeah?
So what sort of carbon level would be considered sustainable?
That's all a matter of personal preference, right? I mean, obviously we want to all try to get to net zero, but actually that's kind of a good lead-in. So I have some tips on the next 2 pages on ways you can reduce your footprint, but it's going to depend on your situation, right? So some people have more purchasing power or they're about to build a new home. That's a huge opportunity to be net zero. If you have a lower income or you have kids in college, you have these other economic factors, you may only be able to do the no-cost, low-cost options for now, or you have to get really creative about it. So it really is kind of a personal preference.
Deb, do you know how many places are putting carbon tax in effect to reduce that?
So I think it was at Vancouver. There's some cities up in Canada that have done it. It's being looked at in a lot of places. Again, I'm not like a huge policy person. I tend to do more of the private sector stuff, so I don't have a good handle on it, but I know a lot of people are talking about it. And a lot of it has to do with, the history of cap and trade and how difficult it was to set the right level for those caps to be effective. And all of the issues with carbon accounting makes it really tricky to figure out who to push on and who not to push on, depending on what they're including or not including in their footprint. So a lot of people are looking at carbon tax as a more elegant solution, if you will, but there's obviously a lot of resistance to that too.
I plugged in coolclimate.berkeley.edu.
Yeah.
And redirected to coolclimate.org. Is that the?
Does it have that picture kind of like a landscape across? Yep, that's it.
That's it?
Yep, that's it. Yes?
What? I can't read what's up there, but there's a website up there. Are there websites or is there a way of downloading any of what you gave us today? Or
yeah, actually, that was a question for you guys. If I give you my slides, is it something you can send out to the mailing list or like as a link, or what's the best way to get this out?
Good.
Okay, all right, so I can host it on my website, and then if you guys want to send it as a link, because there is a lot of stuff embedded in here, and I wasn't sure how to share it.
Yeah, that's great. That'd be great. Thank you.
Yep. So what I tried to do, because there are a million ways you can reduce your carbon footprint, you saw on that list of actions, right? I just put some of like the top things that come up over and over again, and I tried to include no cost and higher cost items because it depends on where you are and what decisions you're making, what purchases you're doing. Obvious ones, turning off your lights, unplugging your electronics. Recycling and composting does have a longer term benefit, so keep doing that even though you don't see it day to day. So what some people are doing in terms of what they're eating is doing a Meatless Monday. So maybe you don't go all vegan because that's a huge leap, right? But if you can pick one day a week that you say, every Monday I'm going to try to have a vegetarian meal. You're tiptoeing into this world of having kind of a lighter carbon footprint. It's not as drastic. You can kind of drag your family along and get them to go along with you. The next one is signing up for the free Mass Day of Home Energy Assessment. So I've done 2 of these since I've lived here. The first one was very basic years ago, and I didn't really get a lot of information out of it. The one I did, I think the last one I did was about 3 years ago. And they actually took all sorts of measurements and gave me a report and gave me a list of measures, and those measures had costs associated with them, annual savings, and the amount of incentive money they were going to give. And they also have contractors that say, if you want to pursue these measures, we'll get it done for you and we'll complete all the rebate paperwork. So they're really trying to make it easy to do the efficiency projects that are within your home. And a lot of them are what we call low-hanging fruit projects. So when they come to do the assessment, they will swap out your light bulbs on the spot. You don't have to pay a dime. So if you have incandescents, I don't know if they're still doing it for CFLs, they'll put LEDs in there right when they come to do the assessment. They'll give you smart power strips, so if you have a lot of electronics, you plug all your electronics into that power strip, and as soon as something goes into kind of sleep mode, it automatically shuts everything off, so you're not, pulling power just by having stuff plugged in. And then beyond that, they'll make recommendations for things like air sealing, insulation, maybe swapping out equipment if you need to do bigger projects as well. And then with the transportation thing, so no cost, lower cost, make sure that your engine's tuned up, checking the tire pressure. These things can actually increase your miles per gallon by a certain percentage, so 3 to 5%, something like that. You can look at fueleconomy.gov, it'll give you the stats on that. But just keeping up with your preventative maintenance of your vehicle is just one way to help reduce the amount of gas that you're using. Now, obviously, to get to the bigger items, because people always ask me about the bigger ones, if you're buying appliances, if you're buying electronics, if you're buying office equipment, Energy Star has a product finder. So EPA Energy Star, they certify products to be that are more efficient than standard products. So you can just do a search right on their site and figure out which products are Energy Star, and then you're automatically buying something that you know is going to use less energy than a printer that you just buy off the shelf. It's a printer that's more efficient. If you're buying a new car, everybody wants the hybrids and the electric vehicles. Not everybody can do this. But when it comes time to buy a new car, I highly recommend looking at the Green Energy Consumers Alliance. So this is a nonprofit group, and what they do is they work with all the local dealerships, and they kind of crowdsource and say, give us your best deal for, a plug-in hybrid SUV or, whatever Prius or whatever the models are that are out. So you can actually look dealership by dealership and see what kind of a discount they will give you through this for free. It's a no obligation thing. You just say you're doing a test drive through Green Energy Consumers Alliance, and then they will give you that discount. Yep.
In the cost of the vehicle,
yes,
the electric vehicle, is it implemented how much energy it costs to produce the vehicle?
So how they price them, you mean?
No, how much
the discount?
How much carbon it takes to produce this vehicle?
The beginning of the life cycle.
It depends on the manufacturer, like
Subaru.
BMW, for example, produces their electric cars in a off-the-grid plant, and a lot of sustainable materials put into the cars, and materials that can be recycled.
So I think that's going to depend manufacturer by manufacturer. They're pretty tuned into this. I think they realize, first of all, that there's going to be a big market for electric vehicles. But again, a lot of them are publicly traded companies. Their shareholders are saying, we want you to make your operations more sustainable. So they are looking at it from that standpoint. I don't know if it trickles down to the level of like the consumer and how they set their prices and stuff like that. But, so the other thing that's good about this site is you'll see the discount that you get through them, but it also tells you what the federal and state rebates are. So you might be able to get like a 30% federal tax rebate if it's an all-electric or a plug-in hybrid. And the state actually gives you like $1,000 back on some of these models too. So then you end up, bringing that price back down to something that's comparable to a standard gas vehicle. I think people automatically think, oh my gosh, electric vehicles are so expensive, but it's really, really good to look at the site because then you can say, I'm going to buy a standard gas car, here's the EV minus all these incentives. Maybe it brings it down to a more economic option. And then the last one is solar panels. So people always think solar panels. Again, that's a very pricey option not everybody can do. You can get no-cost solar panels if you do a contract with a third party where they own it and operate it, but you just pay them for the power. So that's one way that people can access it if they don't have a lot of money. If you do decide that you want to pay for it up front, or to get a loan to do it, I definitely recommend using Energy Sage. So if you haven't heard of that site, Energy Sage is sort of an independent company that will vet different solar providers. So they have certain criteria they have to meet for the amount of insurance they have and how qualified they are, different certifications and stuff. And what Energy Sage will do is they will look at your house, they'll pull up a Google map, and they'll design an engineering spec for the project, and then they put it out to bid. So you'll get like 6 different quotes, so you don't have to call all the individual solar providers, and then you go into the Energy Sage platform and it says, here's your system design, here are your quotes, and you can compare it based off of price or warranty or the reputation of the company. It just makes it really easy. We put solar on our house last year, and I spent hours and hours and hours doing this myself and found the variability from provider to provider was insane, first of all. Different levels of credibility and credentials and knowing their stuff. So I think going to an Energy Sage site is really helpful because then you can see, how much should I be paying per watt for my panels and what makes a good provider and who has a good reputation so that you don't have to do all that research on your own. So that is... Yes.
That's a quick question. So I work for a local solar company, and we also do a lot of air source heat pump installations for heating and cooling. I don't know, earlier you mentioned that electric cooling was the least efficient. Obviously we're talking about light bulbs, but I was just wondering what your thoughts were about the most efficient way to heat and cool, and then maybe just like really briefly touch on like what a typical LED home would look like.
Okay, I don't know if I have the answers to all of those. So yeah, to clarify on the electric heating, when I said electric heating is the least efficient, I was talking about the old-fashioned like baseboard systems. The new air source heat pumps that are out there that are all electric are very efficient. So sorry if that causes some confusion. So I'm just talking about those, those electric heaters that you don't want to touch because they're just emanating so much heat. The air source heat pumps is a newer technology that, if you guys have heard about geothermal and ground source heat pumps, that was a big thing for a while. Very expensive to drill the wells, and electricity is really expensive in Massachusetts. So the payback on geothermal is not great, even though it's an excellent technology. What I'm hearing more and more is that air source heat pumps are the most efficient way for smaller buildings, like homes.
Right.
Not as many, like with me in the university world, I don't see a lot of institutional buildings switching over yet because I don't know that, I'm not an engineer by training, so I don't know that it's like a perfect fit for bigger buildings, but yeah, so I hope, definitely look at air source heat pumps. I didn't mean to discredit those. And then what was the second part? The second question?
I was just wondering what like a typical LED home would look like.
Oh, a LEED
as far as,
home. Okay,
as far as where they get their power and how they use it.
Yeah, so I do LEED projects on the commercial side. I've never done a LEED residential side. But I can give you kind of the 5-minute version of LEED and how it works. So LEED gives you kind of a menu of options. They have credit categories, so it's things like, is it a sustainable site? How are you addressing energy and atmosphere? How are you addressing water efficiency? How are you addressing indoor air quality? And underneath that, they have different ways that they measure those benefits or impacts. So you accrue points for pursuing different things. So it could be you do an energy model of the building, and you implement a bunch of energy conservation measures, make it high insulation, air source heat pumps, dynamic controls, that sort of thing, reduces the energy use. For indoor air quality, you would be using low emitting materials, for instance. So if you've ever painted with traditional paints, you have to open all the windows and you get a headache right away. If you do no VOC paints, there's almost no odor at all. It's actually just much healthier for you in the long term. So there's different ways that people approach LEED. It's not all about energy. It's about kind of a whole holistic approach to sustainable buildings. So each, at least from what I've seen in the commercial side, is LEED projects are very different depending on the owner and what's important to them. So some may have a very energy efficient building because energy is number one. Others might have, really good views with lots of windows and views of nature and lots of natural light and really good ventilation systems because the indoor environmental quality is the most important piece to them. So it depends on the project.
Okay. Awesome. Thank you.
Yeah. Okay. Oh, good. We still have 20 minutes for questions. So I'm actually, that's it. I know we covered a lot today. So feel free to keep asking questions.
I'm still confused about unplugging. You're saying if you turn off a power strip, you don't need to unplug it? I mean, I go nuts, plugging everything every day.
Okay, yeah, so let me clarify that one. So things like your there's none here, but cell phone chargers, laptop chargers, people got really used to the idea of instant on. So what ended up happening was, in the old days, when you would turn on the TV, you'd have to wait for it to warm up. I don't know if you guys remember that. And now it's like, boom, you hit the button and it's instantly on. The reason it's instantly on is because those power supplies are constantly drawing a low amount of electricity, just for that convenience factor. So there's this thing called phantom load that we're finding more and more is becoming an issue and drawing, greater energy use in homes because we have all these chargers plugged in with nothing even attached to them half the time. So if you don't have a smart power strip, you do actually have to go around and unplug everything. But if you do one of those home energy assessments, they will give you smart power strips. And the way the smart power strip works is that it actually kind of monitors the amount of electricity that's being drawn from what's plugged into it. And it has kind of a master plug. So if your laptop is, like in my home office, my laptop is my master, the thing that's plugged into that master plug, right? So if I'm actively using my laptop, it knows that I'm busy in my office and it keeps everything on. If my laptop goes into low power mode, that smart power strip recognizes that drop in consumption and it kills the power to everything that's plugged into that strip. So if you have your printer and your charger and your light and everything else on that one strip, as soon as this goes, okay, I'm going to shut down for a while, or I'm going into sleep mode, the whole thing goes off. So then you don't have to manually turn things on and off.
Do you have to turn it back on?
No, so what it does is, if you go into if you power this off, you'd have to power it back on. But if it goes into sleep mode, if I tap on the laptop and the laptop just ramps back up, it turns stuff on.
So the power strip knows.
The power strip knows.
So how does it know?
Well, there's like one plug where the computer would be, and that's sort of like the governor, and any ancillary that runs off of that, like a printer and so forth, if it sees the master go down, it just shuts the ancillaries off. And then when the master comes back up, then it turns power back on to all the ancillaries that might be associated with that.
And I think what's happening with the new building code is a lot of the new outlets that are being installed in buildings have that smart capability now too. So newer buildings are going to, be smarter and kind of shut things down if they're sensing that lower draw. But it's not in all existing buildings, just new construction. So, yeah.
My Comcast cable box seems to be on all the time. I can hear it on it.
Yeah.
Can I put a smart power strip on that? Is it going to impact the internet in my house? Or?
If it's your modem, it would. Yes, it would impact it. So there are certain things you'll probably have to keep on. But if it's just your TV and I think the modem is separate from the cable box. I'm not the IT expert. Yeah. So if your modem is the always on outlet, but everything else is on that smart power strip, it'll take a little bit longer when you turn your TV on. That's how ours is, and we have a Roku and we have the cable box. So when we go to reactivate it, you have to wait for it to kind of boot up, but it doesn't impact anything. It still runs fine.
Well, I have my modem connected to a cable input in one area of my house, but then the television and all that is connected to a different cable input. So it sounds like if I just dealt with the one that is next to the TV, I wouldn't touch my modem at all, and so it wouldn't impact my internet usage.
That's how I would try it, and I'm pretty sure that's how we had it set up in our house. Just leave that modem on because you need the Wi-Fi to be on all the time. But otherwise, the other stuff can go on and off. And people criticize and say, well, it's not good to turn the laptop on and off every day, but studies have shown that it doesn't reduce the lifespan of the product. So, yeah. All right.
I just wanted to make a comment about vehicle. That's actually my own business, and I see a lot of my customers driving gas-powered cars, and I actually see problems develop as pertaining to how they drive them. So you can buy a car that gets 30 and 40 miles per gallon, but if your drive is 5 to 10 minutes long to the train station, you're not getting 40 miles per gallon, you're getting like 15. And you're driving the car during an emission cycle where nothing's really being monitored because the car's being warmed up. It's actually the dirtiest cycle for the car to run in. And it's also really detrimental to the mechanical operation of the car because it's always running on cold fluids. So you might have this car that has hardly any miles on it, but it's been driven 2 miles at a time all its life, and it's really got about 100,000 miles of wear on it with 25,000 miles on the odometer. So if you're going to do your carbon footprint and you look at your vehicles, look at how you drive your car. If you're the kind of person who drives for less than 10 or 20 minutes, a hybrid or an electric vehicle is really the kind of car for you, because the electric, most of the hybrids run 25 or 30 miles electric, because the car companies know from the data and driving analysis that most people do a lot of short trips in their daily drives. And so if that's the kind of driving you do, then you'll be driving under electric mode most of the time. And if it's a hybrid, you got your gas backup if you want to take a longer trip. So the other thing with the electric cars, when they're running in electric mode, is they don't need to warm up. It's like a light. It's either on or it's off. And so they tend to be a lot more reliable for the person that does a lot of the short trips. I switched my wife to an electric car because she's the person that somehow accumulates 50 or 75 miles a day, 10 minutes at a time. And when she was driving a gas-powered car, there was a huge gas bill. The car had a lot of these cold start running problems associated with it. And when I switched her over to an electric car, we also put solar panels on the roof. All of those issues went away. And she's a bit more conscious about how she drives because she has to manage it a little bit. But it is sort of a hybrid. It's got a gas-powered generator as a backup, so she doesn't have to do the math and run out somewhere. She can still get back home. But that's just something to think about. And right now, because fuel has generally been fairly cheap, the prices on used electric cars and hybrids is fairly low. So if you want to get into an electric car, you can't afford a new one, and your driving style is sort of one of these ones where you're not really traveling a whole lot, it might be a good opportunity to buy one. The other thing, with the electric cars is, if you're really concerned about range anxiety, what we decided, we have some other cars as alternatives for long trips, but there was a time we didn't. And one time we had to do this trip around New England to check on colleges, and so we were going to do 1,200 miles. Well, the electric car wasn't going to do that. So we just rented a car from Enterprise, and it ended up costing $90 to rent the car for 3 days, and we got a fuel-efficient one, so the gas was hardly anything. So that's an alternative. So if you're really not doing these big monster trips, don't let that sway, you purchasing a fuel-efficient car, because you can just rent that car for the long road trip that you infrequently do. But anyway, that's all I got to say about that.
That's a good point. Very good.
So I want to thank Deb. That was a great. Detail that she's been working on with this project in the City of Newburyport, and I'm glad to see all of this come out. And
there will be more.
And there's going to be more.
So at the Green Expo, I have like a little 20-minute talk.
Yep.
That's going to be focused on that city footprint. So you guys gave me a lot of good ideas for what I need to add to that presentation. So thank you for the questions.
All right. Well, thank you very much for coming.
Okay, Deb.